Before we start looking at polynomials, we have another property of graphs that we need to talk about, and that is what's called extrema. It looks like extrema, but it's extrema. And when I talk about extrema, I'm really looking at maximums and minimums on my graph. Maximums and minimums. So if I come down here, it actually is property number 6. Not that that matters, but you can change that. Property number 6, extrema. When I talk about maxes and mins, there are two different types. There are what we call absolute and what we call local or relative. And the best way to see the difference for me is always to come over and think about a mountain range. I always look at a mountain range like the one up here. And if I think about it, I can see where these different maximums are occurring. All of them right here. But there's one maximum that is what we might say more maximum than the others. It's that guy right there. He would be the absolute maximum of the mountain range. So he would be the highest point. Here we're going to put highest or lowest, because we're talking about minimums also. Highest or lowest point on the graph. So when I talk about absolutes, I'm looking for the absolute highest or lowest. And again, that's this guy right there. But I also have these other peaks as I go that I pointed out before. That one, that one, that one. They're also maximums, but they're only maximum compared to the points that are right around it. So he's what we would call a local maximum. He's only a maximum in that one little area. So I'm going to define this as the points that are higher. I'm going to put / lower than the points immediately on either side. So it's a maximum or a minimum, but just in that little area. Not overall, just in that little area. So for an example that looks more like a graph, if I had a graph that kind of looks like this, I just need the shape of this. I don't need it to be exactly in any sort of location. If that's my graph right there, and I want to identify the maximums and the minimums, right up here would be a maximum, and down here is a maximum. Specifically, this one would be an absolute max, because he's taller than all the other points on that graph. And this guy down here would just be a local maximum, because he's only taller than the points immediately on either side. And again, local or relative for that maximum. Down here, we're going to have a minimum. Now, if I reason through if he's an absolute or if he's a local, I can look at, well, specifically all the other points down here that are below him. And one thing to definitely look for is an arrow. If an arrow is pointing down, that means the graph goes down forever and cannot have any sort of absolute minimum. So every minimum would have to be local. So this graph would have an absolute max, a local max, and a local min. There's not much more to this idea of extrema. Some practice problems down here to try. Just one thing that I want to point out, if you look, let me scroll back down. If you look at example 2, right here, a lot of people get confused when it comes to that point right there. What's happening at that point? And if we look at it, he's not going to be a max or a min, but he's one point that we've already talked about, specifically a point of inflection. He's a point of inflection. The concavity changes at that point from concave down to up. But an important thing to note is that a point of inflection is not an extrema. So points of inflection are not extrema. They're just where the concavity changes. And taking that the opposite way, a max or a min is not a point of inflection. They're not the same thing, and they never will be. So differentiate between maxes and mins, which are the highest and lowest values, and the point of inflection, which is where the concavity changes. So go through, try these other examples out, check the answers, and make sure that you have a good handle on extrema, maxes and mins.